Hey, before we get into this one, I want to be straight with you. I do my best to verify every story I tell on this channel. I dig through old documents, cross-reference sources, and try to get as close to the truth as the historical record allows. That's the deal. You show up, I do the homework. This story? This one's different. The tale of Arthur Woodruff comes from a small handful of sources, a summarized classified report, some local history accounts from the late 70s, captured German signals logs referenced but not publicly available, and a single line in a 1997 obituary. I went looking for independent verification. I searched archives, museum collections, genealogy records, engineering histories. And I'll be honest, I couldn't nail it all down. Some of the details may have been embellished over the decades, some may be exactly as they happened. I can't tell you with certainty where one ends and the other begins.
But here's why I'm telling it anyway. The principle at the heart of this story, that amateur ingenuity punched above its weight in the radio war, that the boundaries between bedroom and laboratory were more permeable than official history admits, that part is documented. That part is real. And the story, verified or not in every detail, captures something true about what this hobby has always been about. So take it for what it is, a remarkable tale, told as faithfully as the sources allow, with a healthy respect for what we know and what we don't. Fair enough? Good. Let's get into it.
Picture this. It's 11 o'clock at night, summer of 1943, and somewhere along the southern coast of England, a bedroom window is glowing orange. Not from a lamp, from vacuum tubes, 9 of them actually, wired together in a way that no textbook described. Powered by a generator that a 14-year-old kid salvaged from a broken-down lorry. The whole contraption is aimed south-southeast, across 30 kilometers of dark water, directly at Hitler's Atlantic Wall. Now, at that exact moment, entire departments of the British government are spending millions of pounds trying to solve a single problem. Bletchley Park, the post office research station, they are trying to figure out how to jam German military radio across the English Channel. And this kid in his bedroom in Kent, he might have actually done it. His name was Arthur Woodruff. I need to say something right up front. This story lives in that grey space between history and legend. The specific details come from summarized classified reports. No surviving hardware, no museum artifacts, but that makes it more interesting, not less. So here's what the sources agree on. Arthur had been a wireless nut since he was 9, when his uncle gave him a crystal set and a copy of the Radio Society of Great Britain's handbook. By 12, he'd built his first receiver. By 13, and this matters, he had a working transmitter. Unofficial, of course, entirely without the knowledge of the authorities. He was using it to send Morse code across the rooftops to a school friend 300 meters away. No formal training, just library books and back issues of Wireless World. But Arthur wasn't just tapping out Morse for fun. He was listening. He was listening to the clipped, urgent transmissions of German army units along the Atlantic Wall. Artillery nets, navigation beacons, the whole machinery of occupation chattering away. And one day, Arthur got an idea. See, here's the problem nobody had solved. Jamming German radio wasn't new, but every approach had a catch. The RAF had aircraft, but it was dangerous. The airborne cigar system used modified bombers carrying high-power transmitters. It worked, but it was basically a billboard saying, hey, we're jamming something. The post office had ground-based jammers. Purpose-built, bulky, expensive, and they needed trained operators. They were decent, but limited in range. Then there was Aspidistra, the monster. A 600-kilowatt transmitter buried in an underground bunker. It was magnificent and cost millions. What nobody had managed was persistent, wideband, ground-based jamming that could blanket a broad swathe of territory from a fixed position, continuous and safe. Official estimates said it couldn't be done without infrastructure. Arthur hadn't read those estimates, so he built one anyway, in his bedroom, between homework and supper. Using 9 repurposed domestic wireless valves, the kind in any radio, he built a broadband noise transmitter covering 3 to 12 megahertz, right where the Germans lived. The estimated output power, somewhere between 800 watts and 1.2 kilowatts. That's some serious push from a bedroom in Kent. Now the antenna, Arthur built a directional array. Wire elements between wooden poles in the back garden, oriented south-southeast. Functional and clever. It was similar to a Yagi design, though he'd arrived at the principle through pure experimentation. He noted it pushed harder in one direction. And it did. The first results showed up in late June 1943. German army signals units started logging interference complaints, specifically in that 3 to 8 megahertz range. Captured German signals logs described the interference as hex-persistent, directional, and apparently British. They thought it was a powerful military installation. They were right about the direction. They were spectacularly wrong about the scale. It wasn't a military base, it was a kid's bedroom. Meanwhile, the French resistance, the scientist circuit, reported that German ground communications became noticeably unreliable during those evening windows. During those windows, they could operate with reduced risk. The Germans were too busy dealing with interference to hunt for clandestine transmitters. The timing lines up, the frequencies line up, and the story of how it all came apart is almost as good as the story of how it started. A neighbour noticed the jerry cans, the late-night generator noise, the unusual aerial arrangement. Being a proper wartime citizen, the neighbour reported it. The constabulary contacted the civil defence. They contacted a post office radio investigation inspector named Ernest Hartwell, a former wireless engineer. Hartwell showed up on a Tuesday in September, fully intending to issue a caution. Then he saw what Arthur had built. He asked if he could sit down. His report described the construction as crude, but the theory as ingenious. He recommended immediate referral to the Signals Directorate. Now, here's the part most people don't think about. Arthur's transmitter cost maybe £4 and occupied the volume of a small trunk built by one kid. Across the channel, the Germans were running operations with tens of kilowatts. The British and Americans invested millions in massive industrial manufacturing capacity. And then there's Arthur, with 9 valves and a stolen jerry can. His transmitter was a proof of concept nobody asked for, a demonstration of imagination. The electromagnetic spectrum, if approached with enough imagination, offers returns wildly disproportionate to the resources invested. Ham radio operators still live by that. What happened after? The story gets slippery. Some say he was recruited as a consultant. Others say they just told him, firmly, to stop. He was never prosecuted. Arthur went into research. His 1997 obituary mentions experimental radio work during the war. Nothing more. Obituaries rarely mention the most interesting things. No surviving example of Arthur's transmitter exists. No exercise book. No museum has his work. And maybe that's fitting. The principle is what matters. The boundaries between amateur and professional were more permeable than institutional history likes to acknowledge. Many advances came from ideas like Arthur's. That's the ham radio story. The idea that someone alone, with modest equipment and a good antenna, can reach farther than anyone expects. You can do the impossible. Every time you work someone you shouldn't be able to, too much distance, too little power, you're proving what Arthur proved. The spectrum rewards imagination. So I'll leave you where we started. Summer of 1943. A back bedroom, valves glowing orange, a wire antenna aimed across the channel, looking in the right direction. The Germans logged the interference and went looking for a powerful installation. They were looking in the right direction. They were looking in the wrong place. Now look, whatever you do, don't subscribe to this channel, seriously. Because if you do, you might accidentally learn something you can't unlearn. Before you know it, you'll be at a hamfest telling strangers about a 14-year-old kid who jammed the Wehrmacht. People are going to think you're making it up, which is exactly what the Germans thought too. Subscribing is just going to cause you problems. 73, and I'll catch you on the next one.